I'm going to explain what is accelerated motion. You know, if a body covers equal displacement in equal interval of time, body is said to move with uniform velocity. If the velocity changes from instant to instant, body is said to move with acceleration. Accelerated motion, there are two types. Uniformly accelerated motion. If the change in velocity per unit time is a constant, then it is known as uniformly accelerated motion. Example, if you drop a pen from a certain height, its velocity is going on increasing. So it's the increase or change in velocity per unit time is constant. So you know acceleration due to gravity is 9.8 meter per second square. So that's an example for uniformly accelerated motion. Then non-uniform accelerated motion. If the change in velocity per unit time is different or if it is not constant, then it is known as non-uniformly accelerated motion. Now let us see what is the average acceleration. If the velocity is changing, body is said to have acceleration. Average acceleration. Suppose the velocity of a moving body changes from v1 to v2 in a time interval delta t. Delta t is t2 minus t1, where t1 is the initial time and t2 is the final time. So change in the time is t2 minus t1. That's the interval. Now average acceleration is v2 vector minus v1 vector. That is the change in velocity. You divide by the change in time, delta t. So that is delta v by delta t. So average acceleration is delta v by delta t. Then let us see what is instantaneous acceleration. You know, average acceleration is delta v by delta t. Delta v by delta t, when the delta t tends to 0, so then this is called dv by dt. So this ratio delta v by delta t in the limit delta t tends to 0 is known as instantaneous acceleration. In calculus it is denoted by dv by dt. So instantaneous acceleration, or you can say acceleration, is dv by dt, rate of change of velocity. Acceleration is the rate of change of velocity, dv by dt. Change in velocity. So dimension of velocity is lt raised to minus 1. Then time, change in time, dv by dt. So its dimension is t. So this can be written as lt raised to minus 2. So dimension of acceleration is lt raised to minus 2. Then its unit is meter per second square. If the velocity is increasing, body is said to have positive acceleration. If the velocity is decreasing, it is said to have negative acceleration. Negative acceleration is known as retardation or deceleration. In component form, you can write like this: acceleration is equal to dvx by dt I cap plus dvy by dt j cap plus dvz by dt cap. This is the change in velocity, rate of change of velocity along the x-axis. So it is acceleration along the x-axis, dv by dt, dvx by dt, that is acceleration along the x-axis. This is dv by y by dt, rate of change of velocity along the y-axis, that is acceleration along the y-axis. Then this is the rate of change of velocity along the z-axis. So it is dvz by dt is az. Now you know velocity is the rate of change of displacement. So this Vx can be written as dx by dt. So this can be written as d square x by dt square. So this can be written as d square x by dt square I cap plus this is d square y by dt square. This is d square z by dt square k cap. Now from this we can write dv is equal to a dt. So this is a velocity time graph. Its slope will give you acceleration. This is a change in velocity, this is a change in time. The slope of the velocity time graph will give you acceleration. If you integrate this, integral of dv is v, then integral of a dt. Time is here, time is the variable, time is changing from t1 to t2. So you can get velocity by integrating. In this video, let us see equations of uniformly accelerated motion by calculus method. First of all, let us see velocity time relation between velocity and time. You know that acceleration is the rate of change of velocity. So a is equal to dv by dt. After rearranging, you can get dv is equal to a dt. This expression you integrate on both sides. The side variable is velocity. Initially velocity is u, final velocity is v. This side variable is time. Initially time is 0, finally time is t. Integral of dv is v. Then apply the limit, lower limit u, upper limit v. A is a constant because it's uniformly accelerated motion. So a is constant. A can be taken outside. Then integral of dt is t. Initially time is 0, finally time is t. Then apply the limit. Here upper limit is v. So substitute v minus lower limit is u. So u. So v minus u. A constant, then t. Upper limit t minus lower limit 0. So take this minus u to the other side. So v is equal to u plus at. So this is the relation between velocity and time. So v is equal to u plus at. Next, displacement time relation. Here we have to start with this relation. Velocity is rate of change of displacement. V is equal to ds by dt, or ds is v into dt. You know this relation. V is equal to u plus at. So for this v, you can write u plus at. So ds is equal to u dt plus at dt. After removing this bracket, then integrate every term. Here integral of ds. Here variable is displacement. Initially 0, finally s. Here when we integrate, integral of u dt, here time is the variable. Here time is changing from 0 to t. Here uniformly accelerated motion, so a is a constant, take it outside. Then integral of t dt. Initially time is 0, finally time is t. Integral of ds is s. Then limits, lower limit 0, upper limit s. U right outside. U is the initial velocity. Integral of dt is t. Initially time is 0, finally time is t. Integral of t is t square by 2. Then limits, lower limit 0, upper limit t. Apply the limit s minus 0, upper limit minus lower limit. So s minus 0 u. Here upper limit t, lower limit 0, so t minus 0 plus a, upper limit t, so t square by 2 minus lower limit 0. So s is equal to ut plus half at square. So this is the relation between displacement and time. S is equal to ut plus half at square. Next, velocity displacement relation. Acceleration is rate of change of velocity. So a is equal to dv by dt. This expression you divide by ds and multiply by ds. So dv by dt, dv by dt. So when you divide and multiply by same ds, there is no change. but ds by dt is velocity. Now this expression a is equal to dv by ds into v can be written like this. A is equal to half dv square by ds. So now dv square by ds. So differential coefficient of v square with respect to displacement ds, that is v square 2v, differential of v square is 2v, then differential coefficient of v is dv by ds, then this half, so this 2 will get cancelled, so v dv by ds, so v dv by ds can be written like this. Now this, after cancellation of these two, it is v dv by ds. So v dv by ds can be written as half dv square by ds. You rearrange this and get an expression for ds. So now ds is equal to 1 by 2a dv square. Next, integrate on both sides. So this side integrate. So here variable is displacement, initially 0, finally s. This side variable is velocity, so initially u, finally v. Acceleration is a constant, so 1 by 2a is written outside. Then integral of ds is s, then apply the limit. Integral of dv square, integral then differential of v square, so it will be v square. Integral of dv square is v square. Then apply the limit. Lower limit is u, final upper limit is v. Then apply the limits s minus 0, so it is s. Now 1 by 2a, upper limit is v, so v square upper limit, v, apply the upper limit v square minus lower limit u, so minus u square. Now after rearranging, you can write like this. Take this 2a this side, so it will become 2as. Now minus v square the other side, so v square is equal to u square plus 2as. Now one more relation is there, relation which is connecting the average velocity and displacement. U is the initial velocity, v is the final velocity, so u plus v by 2 into t. Now let us derive that relation. V is equal to u plus at. So after rearranging, you can get at is equal to v minus u. Then s is equal to ut plus half at square. Then that can be written as s is equal to ut plus half at then t square. So you write separately t, at then t. So for this at we can write v minus u. Now you remove this bracket, half Vt minus half Ut, Ut minus half Ut, that is half Ut, then plus half Vt. Here T is common, so you take T outside. So we can write U plus V, then this half is also common, so write outside. So U plus V by 2 into T. So now these are the equations of motion. V is equal to u plus at. Here velocity time relation. Here displacement time relation. S is equal to ut plus half at square. Here velocity displacement. V square is equal to u square plus 2as. Then here initial velocity u, final velocity v. So u plus v by 2 into t. So displacement is u plus v by 2 into t. Thank you for watching.